Now let's look at the formal definition of the Big Theta notation. So for a given function, g of n, we will denote by big theta of g of n to be the set of functions, to be a set of functions. So recall that the big theta notation is defined upon a function. So big theta of such the g of n function is a set of functions. Okay. And this set can be described by this mathematical language. So for those functions in the set, we call it f of n, and there exists a positive constant c1, c2, and the n0, such that the function f of n is greater or equal to c1 times g of n, and smaller than or equal to c2 times g of n for all the n that is greater than or equal to n of n0. Okay, so as long as the function is satisfied by these conditions, it is in this set. Okay, and this set is denoted by the big theta notation. Okay, so this is a very abstract and formal language in mathematics. So these sets actually describe a function that belongs to the that satisfies such a property. So it can be sandwiched. It can be kind of sandwiched between c1 times g of n and c2 times g of n, as long as the n is sufficiently big, as long as it is bigger than some threshold. Okay. So because this is the big theta of g of n is a set, so strictly speaking, we should write that some particular function fn belongs to such a set or is in the set. But usually we will write, use the equal to simplify the writing. Okay. So actually intuitively, this big theta notation can be understood quite easily, because if we have a plot like this, then you will see that basically the big theta notation says that for all the values that is greater than n0, as long as n is sufficiently big, greater than n0, then the value of the function lies between c1 times g of n and c2 times g of n. And we use big theta to denote such a relationship, denote such a sandwich relationship. So in another way, we say that g of n is an asymptotically tight bound. Okay. Here we use the term tight because there is both lower bound, which is c1 times g of n, and upper bound, c2 times g of n. So here's so this is the formal definition and intuitive demonstration of the big theta notation. And in the next, and one more thing here, it also requires that every member in the sets Fn and Gn, G of n, they themselves are asymptotically non-negative. So that is also straightforward, because if it's a negative function, then there's no way that the greater than 0 condition is satisfied, right? Because we have included the greater than 0 condition here. All right, So next, we're gonna go through some examples showing what kind of functions satisfy the or can be described by the Big Theta notation.